So hi everyone. In previous video that we learned about how to download SRTM from Google Earth Engine to your local drive. Then now I'm going to start the new phase where we will be using this digital elevation model on hydrological purposes, like how we can use this data to create a number of layers which is useful in hydrological perspective. So first of all, the digital elevation model that we downloaded from Google Earth Engine will be on the projection system of WGS 1984, which will be, I think, geographical coordinate system. So whenever we are working on, especially on uh, let's say on hydrological perspective, then it is preferable that you always use the local projected coordinate system that you have to use for that specific area. So for that, how we are going to convert this data from geographical coordinate system to uh, the specific coordinate system that we have to use. Okay, for that I'm going to create a new database for this specific project. I will just go and browse the folder where I want to locate this specific database, and you can just click on this browse option, and it will give you an option on where you can just go and locate your specific folder. So I'm going to work on inside this folder, and this is the hydrology. Under practice there is a hydrology folder, so I'll be working on this folder. So I'm just giving this location. Then I will rename my folder for hydrology, let's say one. You can give any name based on your requirement, and you can create a folder under this project by selecting this tick and just click on OK, and it will take its time, and it will open the specific folder on where you are going to get the map, right? Okay. So yeah, this is the default map view that I'm getting since I'm located in this area. So you can see this area is zoomed. So first, what I want to do is I want to add the folder in here, so that now you can check in the under the catalog. Under the catalog you can find like there is only database connected, so you cannot see any other information over there. That's why I want to add one folder. So in that case, you can just right click on the folder and click on add connection folder. Then you can browse to the specific folder which you want to connect. So I'm connecting this hydrology folder. So click OK. Now you can see there is a hydrology folder that is connected over here. Why did I connect it? Because so that I can see whatever that is present inside this folder, all the layers can be seen on this catalog option, and you can just drag and drop in your specific area to get that information, right? So I'm going to use this data set. I will just select and drag this folder to the map view or map, this is content section. You can do either. So the best idea is to drag in this way, because it will help in aligning the layer as well. So that is how you do it. And when you are loading the data sets, it will always build the pyramids and calculate the statistics, so that whenever you are working on those data sets, it will not create problem in later. So this is the data sets that we download previously. So we have digital elevation model. You can see there are lots of minimum elevation value, right? Okay. So before working on this data sets, what I will do is I will always project this data sets to the specific local project system. It is not compulsory, you can do as your own, but now I'm working on the specific British Columbia area of Canada. That's why I'm just trying to project the coordinate system into EPSG 3005, which is the local coordinate system over here. So you can always check which processing system is there in your data sets. You can right click on the data sets and click on properties, and under the properties you have to go to the source. Okay, you here you go to the source and check the special reference, right? Okay, so once you go there, you can see this is Geographic Coordinate System with WGS 1984 with EPSG 4326. So in this case, we are converting this EPSG 4326 to EPSG 3005, which is the BC Albers projection coordinate system. There are a number of coordinate system that is used in British Columbia. For now, I'm just using this BC Albers coordinate system, which is projected coordinate system. Okay, so I'm just going and clicking over there on that site, and you can go to your geoprocessing tools. If geoprocessing tools are not available over here, then you can always go to the analysis sections and click on these tools, right? Once you click on these tools, you will get this geoprocessing tools. So what we need here is we are going to project the coordinate system of the raster, right? So you can directly search project raster, or you can go to the conversion tools, so whatever is easy for you. So under this data management tool, you can find this project coordinate system, project raster tool. You can just simply click on this, right? Okay, let me just wait for a while. Okay, yeah, great. So the first thing first, so you have to provide the input raster. The input raster is SRTM that we are using. Either you can just directly select from the list, or if it is not working from here, then you can drag and drop over here. That is also an option. And also, if it is not working, sometimes if you have space or anything hyphen in your folder name, then it will create a problem. So in that case, you can always browse from the specific location from where you are going to load the data. This is the three option that you have. You can go here and select this data and click OK. Then you will get this data sets. There are three ways that you can load the data easily. So this is the output raster datasets. You can directly rename your datasets over here. You can see it will be under practice, under hydrology, and under hydrology one folder, and it will be under this geo database. And the datasets will be this datasets will be saved as SRTMDM project raster. For now, I don't want to name it as like this, so I will just change to ALB because I'm going to use Albert's coordinate system here. So yeah, this is how you can rename, or always you can do like browse and go to your specific folder wherever you want to save this file. You can go to like any specific folder. For example, if we are working on this, you can go to database as well and rename it whatever you want to do, right? So you have options. Sometimes you can just work outside the folder, outside the database as well, but sometimes you may get error while working outside the folder, so it is always recommended to work inside the geo database so that you will not have any conflict with the coordinate system and everything, right? So yeah, so the next thing is you have to select this output coordinate system. In this output coordinate system, you have to check if there is any layers available with the BC coordinate system. Then you can directly select that. Otherwise, you have to go and browse from here. The select coordinate system. It is like a globe, right? Okay, just select there, and you have this option, right? Okay, over here. Uh, Over here you have to go and find the project coordinate system that I'm using, but it will be very difficult for me to go and find in this list. So I know the projected coordinate system has this name, Albers. So I'll just search for the Albers, and I will go for the national grid under the Canada. So this is the coordinate system that I have been were talking about. There are other coordinate system that you can check based on your area and specific region, or maybe based on the area coverage of which area that you are working. For now, this coordinate system will work fine for me. And NAD 1983, this is the coordinate system that I will be using. And if you want to check the details, you can always click on the details, and you will find see that I was talking about, the EPSG, that is 3005, that is working in that way. You have the central meridian as minus 106. You have standard parallel of 50 and standard parallel 2 of 58.5. So yeah, this is how this is the information that you can get from these details. So you will always have to check whether you are meeting this information exactly based on your requirement or not. Then only go and select the coordinate system. So once you click here, it will be shown in this area, and then you are confirmed that the coordinate system is selected. Then you can just simply go and click on OK. And once you select on the OK, and you will find that under the output coordinate system, you will find the coordinate system is selected, and also the geographic transformation parameter settings is selected. It is already embedded in the ArcGIS Pro, so you don't have to go and provide what is the exact XYZ transformation, or maybe other scale parameters, or other scale variables that has this coordinate transformating parameters. So you don't have to do anything now. GIS is so easy, right? So yeah, and then you can always select which resampling technique you want to use. It is I don't know, like based on your information, based on your requirement, you can always select which one you have to use. I'm just simply selecting nearest neighbor. Okay, it will just calculate based on the neighboring cells and give you the result. Great. So other than that, you have to select the output cell size. You can always define your cell size, and you have to be very careful on what value you are going to put here. For now I'm using this default value 25.988. It is a default value that is calculated based on transforming the 30-meter resolution of uh, WGS 1984 to this 1983 BC environmental albers. But if you want to work as a 30-meter resolution, then you can simply edit here and type 30 meter for both, or you can always select any resolution datasets that you can select from here if you have options to select the specific file. Okay, and addition to that, if you are changing resampling this value from the default value, then you have to be very careful on selecting this snap raster so that your result will not orient from one place to another. So for now I'm not doing anything over here because I am not giving the specific exact resolution compared to others. So in the case that you have to work on that, you will always have to select that snap raster. Maybe in another chapter, another videos, I may come up with that also. You can check from there. Okay, so great. Once you are done with all these informations, and you put all the information required, you can just simply go and hit the run. It will take time depending on what is the size of your uh, image, as well as sometimes it takes time based on pixel size. So, and also it depends on the speed of your computer, right? So this is it. So you are now able to convert the projection system from one projection system to another projection system, and you can always check these data sets. And for that you have to go and click right click on the datasets that we want to check, and go to the properties. And the same thing, you go to the source and go to the special reference, and you can see the projection system now has been converted from converted to net 1983 BC environment Albers, and the EPSG is 3005, right? So this is it. This is how you can project the coordinate system. And yeah, thank you so much for watching till now, till the end, and I will be coming up with many tools that we use in hydrology. And thank you for the time.